Chapter 7.5, applying tangent ratios, so doing some trigonometry actually, and applying some ratios. So we're going to start basically some trig and using triangles in order to solve for things. So trigonomic ratio is a ratio of the length of two sides in a right triangle. So every time we have right triangles, we get this nice ratio that forms. And then the ratio of the lengths of the sides in a right triangle is constant for any given angle measures. So this ratio is called the tangent of the angle. So we're going to use tangent of an angle in order to determine our ratio of those other two sides of a right triangle. And they're always proportional in this sense. They always have this ratio. So let's look at the tangent. And specifically, let's look at the ratio. So tangent ratio, let triangle ABC be a right triangle with an acute angle A. The tangent of angle A is written as tangent A, or tan A, is defined as follows. So we're going to write this down. So what this means for us is that tangent A, and let's go ahead and draw a triangle before we do this and label it. So we have a right triangle here. Okay, and let's label this. So let's look at A, B, C. We have our hypotenuse. Our leg. And our other leg. Okay, so what this means for us is that tangent A, so tangent of this angle, so we're looking at this angle in here, equals my leg opposite. So the length of leg opposite, so we'll just put leg opposite A. So this equals the leg opposite angle A over my leg adjacent. So leg adjacent to angle A. Okay, so that's what we get for this ratio, this tangent ratio that we have. Now, one thing to note, that we could do the same thing with angle B. So angle A and angle B are complementary angles. Basically, thus we can use the same diagram with angle B. Okay, so just knowing that we can use either angle in order to solve for this. So let's go ahead and look at our first example. So example 1. And in example 1 it says, find the tangent S and tangent R. Write each answer as a fraction and as a decimal rounded to 4 places. Okay. So in example 1, here we have our diagram, triangle ABC, or sorry, next one, triangle STR, and we're going to find the tangents of each of these angles. So let's go ahead and start with the first tangent listed. So we have tangent S equals, so we're going to do opposite of S over adjacent of S. So S is right here. Opposite of S is 80. So tangent of S equals 80. Adjacent to S, the one next to it, is 18. So adjacent is 18. If we take this and we reduce this, we can divide it by 2. We get 40 over 9. And then if you put this in your calculator, 40 divided by 9 is approximately 4.4444. Okay, so that's tangent of S. Tangent of R equals opposite R over adjacent R. So opposite R is 18. Adjacent to R, next to it, is 80. Again, we can reduce this to 9 over 40. And this equals 9 divided by 40, 0.2250. Okay. Example 2, find the value of x. So example 2 we have right here. We want to find that x value using our tangent function. So we'll set this up. And I'm looking at this right here. Get rid of all that. Okay. So find the value of x, and we are given an angle, so let's go ahead and use that angle. So I'm using tangent of A, in this case, equaling opposite of A over adjacent. And then I'm going to fill in everything. So tangent is the value that the ratio that I'm setting up. So tangent, and then A is the degrees. So A is 32 degrees. So tangent of 32 equals opposite. So BC, which is 11, over opposite or adjacent AC, which is x. Now, I can't solve for x on the bottom, so think of it as cross multiplying, like we're just basically multiplying by x to move it over to the other side. So I get this, which is x times the tangent of 32, equals 1 times 11, which is 11. Move the tangent over because I want x by itself, so I get x equals 11 over the tangent of 32 degrees. So then now I can go ahead and put this in my calculator, and I can figure out what my value is going to be. So 11, and let's see if this shows up. So we get 11 divided by, and then the tangent function, so I'm going to put parentheses around this just because I like being thorough. So tangent of 32, close that parenthesis, close my second one, hit equals, and I get this value. So you can type in tangent in your calculator either way. So you get x equals 17.603, and then it rounds to 7, which just means x is approximately 17.6. Using that for my example.